Hi everyone, this is Kona, and I'm going to talk about the data for Project 4. And the biggest reason I'm doing this is just that in previous semesters, this has been kind of a sticking point where students kind of weren't sure or didn't understand exactly what type of data they were looking for, or it was just seemed very confusing. And so they ended up kind of wasting some time in trying to find their data. And then this added to their stress as they tried to do more stuff. So I'm going to try to make this as clear as possible, but if you have questions, please let me know because it's much easier and better for you if you can get some data now uh, instead of later. So like good data now instead of having to go back and forth with it. So for Project 4, you'll be analyzing data you find online. So all of the data is online. You don't have to collect any data to see if the explanatory variables you pick can be used to predict a response variable of your choosing. So the explanatory variables, or the X variables, the independent ones, also called predictor. So I might sometimes go back and forth between predictor and explanatory. So just know they're the same thing. And they actually attempt to explain or predict the observed outcome. And the response variable, which is your Y, your dependent, is actually the measure or the outcome of something. So X and Y. Also, you can also think about it XY axis. So if you're familiar or comfortable with algebra, it's the same thing. Your X is just your explanatory variable, your Y is your response variable. So actually getting started. So to analyze the data you find for Project 4, you'll be doing a simple linear test, and that's with one X and one Y variable, and a multiple linear regression, and multiple linear regressions with more than one X variable and one Y variable. So in this case, it is the same Y variable in both cases, so do not need to find two Y variables. You only need one Y variable, and then you're going to find multiple X variables, and then you'll be doing either the simple linear first and then the multiple linear with all of them. The purpose of these tests is just to see if the variables are related and if one or more of your X variables can be used to predict your Y variable. So for right now, don't worry about how to do the tests. We're going to cover those in the future. We just want to focus on understanding the difference between your explanatory and response variables so you can find appropriate data. So what variables are needed? So you do not have to find variables that are actually correlated, all right? So they do not have to actually be correlated, but you do need to be able to explain why you think they would be correlated or why you think they would be related. So what I mean by correlated, you don't have to find variables that are actually related, but you need to explain why you think they would be related. Come up with a possible response variable. Think of at least 3 explanatory predictor variables, all right, that you think are related to the response variable. All right, but you don't think are directly related. So for example, is the number of people incarcerated for drug offenses related to the number of people incarcerated? Well, yes, because it's all basically the same thing. It's a subset of a total population. Another example would be asking if your math ACT score, the subscore, is related to your overall. Well, yes. It's also true for your predictor variables. So for instance, don't use the percent of whites, the percent of blacks, and percent of Hispanics as your 3 variables because they're so closely related. It's really just one thing, race, not 3. So if you want to use race, then pick a race and use the percent of one of those. All right. And then an identifier variable. And the identifier variable is just how you organize and link the response and predictor variables together. So this is basically how you're able to link them together. So I'm sure at this point you're like, I have no idea what you're talking about. So here are some example variables. So to help you better understand how these variables actually fit together, here are 4 different examples. So here, response variable. My response variable for this one is cancer rate. My explanatory or predictor variables that I think can use to be explained cancer rate are number of fast food restaurants per person, and this is by state because state is my identifier variable, the exercise rate by state, and the obesity rate by state. So even the cancer rate. So literally what you would do, or what I would be doing, is then going online and trying to find all of these rates by state. And the reason I think, because you remember it said you just have to explain why you think they'd be correlated. Well, I think if people eat more fast food, that there's lots of like bad, icky stuff in fast food, and that leads to cancer. Okay, I don't know if it really is. Uh, that's just how I would explain why I think number of fast food restaurants is related to cancer rate. Exercise rate, I think the more people exercise, The lower the cancer rate, obesity rate, I think the more people are overweight, the higher the cancer rate. And I would find these by state. Other examples, suicide rate, I think, and this could be by Illinois County. So I would find the suicide rate by Illinois County, the unemployment rate by Illinois County, high school graduation rate by Illinois County, and the birth rate by Illinois County. And so those would be my response. So this is, I think, these three things can help explain that. Obesity rate, number of fast food restaurants, exercise, hours worked per week. Hours worked per week, I think for that one, I think the more you work per week, the less or the more obese you are, because I think you're just sitting in your office like I am, and you're not out moving and doing things. So I don't know. That might not be true, but that's my claim. That's my idea. For this one, I'm using year. So for this one, I would find the obesity rate for 20 different years, and then hours worked per week. You can actually find how that's changed over the years, what the average hours worked per week is for the US over different years. Exercise rate, so how many Americans are exercising and how that's changed over the years, and the number of fast food restaurants per person and how that's changed over the years. Then suicide rate again, but this is to show how here it was Illinois counties, here it's state, and this time I think suicide rate is related to average number of sunny days. So I think if the more sun you have, the less people are like going to kill themselves because, you know, hey, it's a beautiful day out. Why would I want to kill myself? Average snowfall, I think the more it snows, I think people are happier because, you know, if it snows, you can go out, like build snowmen and like do all sorts of fun stuff outside. Or you could say you're crazy if the more it snows, the more depressed people are. But, you know, whichever, it be your story. And unemployment rate. So see how these things aren't necessarily related? I mean, they kind of are, but unemployment rate really has nothing to do with these two. And that's fine. It doesn't have to. But so unemployment rate, and obviously I think if you're not employed, well, you know, I don't know. It depends. Maybe where you work, you know, you really hate your job. So maybe then you want to commit suicide because you hate your job. Hopefully not. Hopefully you love your job. But I just think these three things are related to suicide rate, and I would find them by state. So the average rate of all of these by state. So what's the actual process of doing this? Go online and try to find numeric data for your one response and three explanatory variables. So remember, you're only finding one response, one y variable, and three explanatory or x variables. So 4 sets of data total. And then they have to have the same identifier variable. So notice in these, they all have, so for this one, all 4 of these have to have the same identifier variable of state. All 4 of these, Illinois County, and you don't have to do Illinois County. You can do whatever county. And you can do any type of identifier as long as everything has the same one. You may want to look up some of these. When you're going online to find this data, you might want to look at this course resources page. You do need at least 20 data values for each variable, and they need to have the same identifier variable. So example, if you're using state as your identifier variable, then you need to find data for the same 20 states for all 4 of your variables. All of your data needs to be in the form of an average rate or some other normalized value. So example, you can't use the number of people who have cancer in each state. And why wouldn't that work? Because California has a lot more people than Rhode Island, but that doesn't mean that more people in California have cancer than people in Rhode Island. It just means that there's more people in California. That's why you have to actually normalize it, or you have to actually find the rate. And to do that, what you would do is find for whatever year you have the number of people who have cancer, you would find the population for that state for that year, and then just divide the cancer rate divided by the total population, or the cancer number, I'm sorry, over the total population, and then that would give you a rate that you could use. So you can use a number, but the only way you can use an actual number that's not a rate is if you then normalize it by finding a number you can divide it by to get that percentage. If you plan on doing this for one of your variables, make sure to explain this. You don't have to do the math right now, but make sure to explain that I'm going to find the total population of California and divide this out, or the total population for all the states and divide this out to get my rate. So just make sure to explain that, but you can do the math later. Provide the direct link for all the data and explain which table or data set you're using from that link if there's more than one data set. Or the page number if you're linking to a document. So basically just make sure it's crystal clear which data set you're using from the link you provide. And why this is important, because some of the websites you might find might have 4 or 5, or more different sets of data, and I don't want to have to guess which set of data you're planning on using. In addition, if one of your tables has like 4 or 5 different columns, explain exactly which column of data you're going to use. So, for example, and this is for your discussion 12, finding data online, this is an example of what's needed for the initial post. So my response variable is cancer rate, and here's my link. So if I open that up, here's my link. And I'm using the all cancers combined incident rates figure, and the rates are per 1,000 or 100,000 people. So that way you know I'm using this table right here, all cancers combined incident rates, and I'm not using this one. See, and this is why it's important to say which one you're using, because you wouldn't know which table I'm using, but I included that I'm using this one. And then you can see, and you don't have to actually get these numbers, but if you mouse over, you get that rate. And what you want to know is that the rates are per 100,000 people and are age adjusted. So that's why this one is okay to use. So that's my response variable. So I think that these explanatory variables, fast food restaurant rate, exercise rate, obesity rate, can help predict cancer rate in a state. So since I'm using states, I need to make sure for these, so for this one, fast food restaurant rate, exercise rate, and obesity rate, I need to make sure that they are also by state and that they're an actual rate and not a number. So this one, Intermap shows exactly how many food restaurants there are in every state. And so if you scroll down, I don't want to zoom in. Okay, and so now, there we go. So I wouldn't use the actual number of fast food restaurants because that's not a normalized value. What I would use is the restaurants per 1,000 residents. So this is the value that I would end up using. Now you don't have to collect that value right now. I mean, you can if you want, because you're going to need it in the next part of this project. But the point is that you do have the correct value, because if I look at like Iowa, it's restaurants per 1,002 or as well. So that's my normalized value. So I'm not using number of fast food restaurants. I'm using the restaurants per 1,000 residents. So then, I can see right there. Okay, this is something that's crazy. Check this out. Wyoming, look at that rate. 95, right? 95.9% restaurants per 1,000 people, 0.95. But that's like crazy compared to, I would think like Florida, you think, a lot of fast food stuff. No, 0.74. That's why it's important to normalize. So California, I mean, look at that. So gosh, Wyoming has, it seems, a lot of fast food restaurants per people when you don't have a lot of population there. So my other one, exercise rate. So for this one, this is a PDF that I found. And if you scroll through, and I already know what I'm looking for, but this is where you kind of have to dig around. Here we go. So exercise rate, it's on, and this is where it's important that you say page 18, table 1, it's the adults, and the adults who met 150 minutes of aerobic activity guidelines, and that is a weighted percent. So for this one, this is why this is page 18, it's table 1, and then see all of these different columns? Well, I need to know which column you're referring to. So I'm saying I'm using this column right there, and so then here it is by state. And I know down here that it's a weighted percent. So that way I know that they've normalized these values in order to keep it approximately equal in order to be able to compare between the states. And the last one, obesity rates, and this one, adult obesity rates for 2015, percent is by population. So for this one, I am using 2015, even though they've got the adult obesity rates from 1990 to 2015. I did say that I'm using the 2015 rates, so this way I can click on, Illinois, and I get a 30%, 30.8%, 32.2, 32. Let's check out Wyoming, 29. That's pretty good. 24.2. Okay, really nice. That information is also right here. And if you go in and look at the rates and the methodology information, you can see that that percentage is a normalized percentage that's based off of the population. So that's where I'm good, and I can use it. So there are my examples right there. My identifier variable is state because I found all of this information by state. So something to think about. And this is eventually, but not this week, you will take the data you found for the project 4 and put it into the mini tab like this example below. So note I only have 5 states listed, but if this was real, you would need at least 20 states if this was real. So this is how eventually you will put it into Minitab. You'll have all 20 states or all 20 identifying variables, and then the rate for each one of your other variables going across. So see how I've got Illinois, I've got the cancer rate, the fast food rate, the exercise rate, and the obesity rate, all for Illinois. And I've got it all for Iowa. And these are all rates. The other important thing, these percentages, I left them as 51.7 instead of 0.517. And that's what you will end up doing. So you do not have to do this right now. It's just something to think about to help you kind of wrap your brain around what you're going to be doing. Right now, the only thing you need to do is just get this information. And so for an example of what you're looking for, so let's say that we want average snowfall by state. You would come over here and you could do average yearly snowfall. Let's just do average snowfall by state. Average snowfall by state right there. Okay, so you open it up and let's see what we have. And they've got state, they've got it by place, but it's okay. No problem. We can do that potentially. And then you've got inches. Holy cow, look at that, 74.5 on average. This is how many days it snows, which you could technically use that as well, or you could use centimeters. But here it is by state. Here's yearly snowfall averages. So states, snow, sun. Here we go. What if that average sunshine by state? Percent sun, total hours, clear days by state. So just to show that here's some ways to do it. You could also, if you want to, current results. Let's see what this one is. Here you go. Here's another one. So just to show, these are some ways. So the biggest thing is when you're typing in and trying to Google it, normally enter in average or cancer rate, like side rate by county, state, race. Remember though, you can't do race because, or if you do, it's not, you can't do race unless you're going to pick one race and it would be a response variable. So you can't really, don't use race. But state, county, this also is for year there, but I'm just going to do state. 20 states with the highest rates, not necessarily, maybe something. Let's try this one. All right. So here's something. So here you've got age-adjusted suicide rates by state for 2012. Why can't you use this the way it is? Because it's too hard to take this and go up and try to figure out exactly, because you have to have exact. So unless you can go through and say, all right, let's try clicking on this one. A downloadable file. So then see if you can go through and try to find the actual mortality multiple cause files. So see if you can go through the actual dates or the actual data here and find it. But otherwise, we can't use this just because you don't have specifics. Here we have some of the specifics. So the age adjusted. So you provide some, but they're not providing all of them. And in all honesty, it's just too hard to try, like, okay, District of Columbia. Well, 5, 6, is that a 6? Is it a 5 point something? You don't know. So in this case, this is a no-go. So we're not using this one. So let's go back to this. CBS News, 20 states with the highest age-adjusted suicide. I think this is the same one as before. Let's try this one. But this is where you're going to have to do a little bit of searching. Let me see, this one's taking a little while to load. So let's look. U.S. suicide, world life expectancy. This would give us, oh, let's see. Suicide stats. All right. Illinois, rank adjusted. Okay, here we go. So this would now work. This one would, because we clicked on Illinois. It tells us the 2014 age adjusted rate is 10.43. We could then go over here, Wyoming, and here you could get whatever states. Utah, wow, that's a lot higher. Texas. So far, Illinois is really low, actually. But so there we go. So we found one. So this is where you just have to kind of do some searching, but it's a rate per 100,000 individuals. And here are the rates that you could be using. So this table would work. So I hope that helps, just explaining how you can find data and what kind of form you need to put into. Make sure you explain which table, the page, all that good information. And please let me know if you have